Hello everyone, welcome back to Ansarkari. So we are taking up the next topic for CSAT, which would be regarding the questions on the basis of this theme regarding the boat and the stream. So there are questions like upstream and downstream, speed of the boat and speed of the stream. So all of this and distance. So it would be speed, time, and distance based questions on boat and stream based theme. So starting with few important facts and the formulas related to this topic. Like there are four things related to these types of questions, like still water, which means that speed of the water in a river is zero, and that is in case of still water when it is not flowing. Stream, so river is moving when we use this term. Upstream is when you are moving against the flow of or against the direction of the water flow, that is upstream, so it is always the opposite. And downstream would be movement along the flow of the water. So in this diagram, the same thing is represented. When it is going against, it is upstream, and towards or in the flow of the river, it is downstream. Now, first formula is if the speed of the boat is suppose x kilometer per hour and speed of the stream or speed of the current is y kilometer per hour. So speed of the boat upstream and downstream can be calculated with these two variables. So speed of the boat downstream would be always addition because it is flowing along the water in the same direction. So that is why speed of boat plus the speed of stream will give us the speed of boat downstream. In case of upstream, it would be minus because we are going against the flow of water. So that friction or the net speed of the boat would be calculated by subtracting these two variables. So exactly on the same formula, we have this question, which is direct application of these values. For downstream, it is x plus y. Upstream, it is x minus y. Now it is another second formula is speed of the boat in still water. It is half of the speed downstream speed plus the upstream speed. If, for example, only these two variables are given to us, and then we have to calculate speed of water in still water, speed of boat in still water. So this would be formula, and speed of the stream would be half, and in bracket downstream speed minus the upstream speed, because always the downstream speed would be more than the upstream speed. So these are some common things which needs clarity to solve the questions. So the illustration states a boat is rowed down a river 40 kilometers. So this is 40 kilometer is distance downstream and time is 5 hours, and up a river, that is upstream, in 21 kilometers in 7 hours. So we need to find the speed of the boat and the speed of the river or the speed of the stream. So direct application of this formula for boat, it is addition, and for speed of the stream, it would be minus. Now, if a man capable of rowing at the speed of x kilometer per hour in still water rows the same direction up and down a stream which flows at the rate of y kilometer per hour. So this is the speed of stream. And then his average speed throughout the entire journey would be by this formula. So we'll multiply upstream and downstream speed divided by man's rate in still water. So man's rate is the speed of rowing, which is x kilometer per hour over here. So that's how upstream is x minus y, downstream is x plus y. Man's rate of rowing is x. So that's how you'll get the average speed during entire journey. Now you need to keep in mind that the distance both downstream and upstream is same. And also in again solving these questions, we need to take care that everywhere the units are same, particularly in case of distance, like sometimes it is in kilometer and sometimes it's in meters. In time, it is in again minutes and hours. So you need to convert them into same units. Then another formula is a man can row a boat in still water. So this is the speed of rowing in still water is x kilometer per hour. Stream is flowing at the speed of y kilometer per hour. Now, if it takes t hours more in the upstream than to go downstream, because more efforts are required to row upstream. and more energy is required. So for the same distance, so we need to calculate here the distance. So that is simply the formula. So we need the speed of rowing the boat in still water. We need the speed of stream. What is the again the time, which is the extra time which is taken to row upstream. If all these three factors are given to us, then we can calculate the distance. So similarly, you can see that a man can row 7 km/h in still water. So this becomes X. River is running at 3 km/h. So this is the speed of stream. This is Y. And it takes 6 hours more in upstream than to go downstream for the same distance. So this is T. So we need to calculate the distance and simply we'll put the figures in this formula. So it is 40 kilometers. Then a man rows a certain distance downstream. So it is for downstream, it is T1 hours and returns same distance upstream in T2 hours. So two different time periods are given, distance remains the same. And if the speed of the stream be y km/h, then speed of the man in still water is given by this formula. So T1, T2, add and then subtract and multiply it with the y km/h, which is the speed of the stream. So although we don't have like exactly same kind of like questions in the UPSC CSAT examination, but it is important that we are aware about these formulas at least. So another is a man can row a boat in still water at 11 x km/h. Stream of flowing is y km/h. If it takes t hours to row to a place and come back. So this is the complete time period given. Then we need to calculate distance between the two places. So that is the formula. And a man can row at now we have again certain illustrations. So I think there will be two illustrations and then we'll start with the previous questions on the same theme. So man can row at the rate of 4 km/h in still water. So this is in still water, and if the time taken to row a certain distance upstream is 3 times as much as to row the same distance downstream. So this is the extra time taken to row upstream. You need to find the speed of the current or speed of the stream. So speed in still water is given, speed of the current, suppose we assume it to be x km/h. Now we can calculate the speed upstream and the downstream because we need these two variables to calculate these two speeds. So it will be upstream 4 minus x km/h, downstream 4 plus x km/h. Now it is given that the time taken to row certain distance upstream is 3 times as much as to row the same distance downstream. So 3 times would be 3 into time taken to row downstream. So we know time, the formula is distance upon speed. So distance remains d, it is same both the sides. So we'll use the variable d on both the sides and we can calculate the value of x by solving this equation. So x will be 2 km/h. Now, this question, it states that in 100-meter race, A beats B by 10 meters. So we can represent it like this. A beats B by 10 meters. So you can say that A is 10 meters. It is ahead of B in a 100 meters race. And similarly, B beats C by 10 meters. So we can say it is the 10% difference, or A is beating B by 10% of the total distance of the race. And similarly, 10% is the case between B and C. So we have to calculate by what distance A beats C. So distance is to be calculated. So in this case, we can write when A completes 100 meters. So B is at 90 meters because A is competing B by 10 meters. So it is 10% of 100 would be 10 meters. And similarly, when B is complete, suppose it is completing 90 meters. So C would be at 81 meters. So how we get this figure of 81 meters is we'll calculate 10% of 90 meter. So 10% would be 9. We subtract 90 minus 9 would be 81 meters. So that's how we can calculate the relation between these three players together. So it would be ratio would be 100 because A completes at 100, B would be at 90 meters and C then would be at 81 meters. So you have to calculate by what distance A beats C. So then it would be the difference between 100 and 81 is 19 meters. So that's how we get this answer. Exactly on the same language, we have another question. So suppose there is 1 kilometer race, A, B, and C. There are three participants. A can give B a start of 50 meter. A is giving a start to B. So B is ahead by 50 meters from A. And C, it gives again, A is giving C a start of 69 meters. So in the same diagram, we can position C at 69 meters ahead of A. So we need to calculate the start which B can give, allow C would be the difference between these two, 19 meters. Now starting with the previous year questions. So when a runner was crossing the 12-kilometer mark, she was informed that she had completed only 80% of the race. So we can say that 80% of the race total 80% of the distance of the total race would be 12 kilometers. And we can simply use unitary method here to calculate like how many kilometers were the runner supposed to run in this event. So we have to calculate the distance of entire race to be run. So 80% is 12 kilometer, 100% would be 15 kilometers simply by this unitary method. In a 500 meters race, so total distance is 500 meters, B starts 45 meters ahead of A. So we have simply written B is 45 meters ahead of A in this 500 meters race, but A wins the race while B is still, it is 35 meters behind. So we can say that when A completes the race, B is still 35 meters behind. And what is the ratio of the speeds of A to B, assuming that both are starting at the same time period? So we can say that distance that would be covered by B, we can calculate like here it is B is starting. The 0 point for B is 45 meters ahead of A. So we will subtract 45 from 500, and when the race gets completed, B is still 35 meters behind A. So we can again, we have to subtract 35 from this 500. So B is running 420 meters in the same time period when A completely runs 500 meters of distance. So this is the distance being covered by B. Now we can calculate the speed of B because time taken by both the players is same. So we can assume time to be T. And similarly, distance covered by A would be 500 meters, the entire distance of the race. And we can get the speed of A. Speed, we know formula simple, distance upon time. So we need to calculate the ratios of the speeds of both A and B. So we have now the speeds. We have to simply find the ratio, that would be 25 is to 21. Now here, this is one interesting question. So X and Y, they run a 3-kilometer race along a circular course of length 300 meters. So the circumference of this entire distance is 300 meters, but you have to complete 3 kilometers. So their speed are, they are in the ratio of 3 is to 2. This is given. Now, if they start together in the same direction, we have to calculate how many times would the first one pass the other. So the start off is not counted as the passing point. So this we need to keep in mind. So we have to calculate how many number of times they would be crossing or passing each other in this race when they are covering entire 3 kilometer of distance. So we can say total distance of the race 3 kilometers. So they will have to complete 10 rounds because one round is of 300 meters. So 3 kilometers in meters would be 3000 meters. So we have to calculate, we are given this ratio of the speeds 3 is to 2. So we can calculate firstly the time 300 by 3x. So we'll, in simpler form, it would be 100 by x. So in tx time, which is the total time, the distance covered by y. So tx time means that the player x in time t is, it is like the total time is this. So covered, taken by x. So in that time only, how much distance is covered by y has to be calculated so that we can calculate their positions in the first round initially. So distance that would be now covered by y in the same time taken by player x. So time would be this value would be used, and distance is to be calculated the speed into time. So 2x into 100 by x, because 3 is to 2 is the ratio of the speeds given. So this is not the total speed. So that is why we use the variable x here. So we will cover the, now we'll get total distance that would be covered by y given the same time period to both the players would be 200 meters. So it states that when X completes this entire 300 meters or completes one round, Y would be at 200 meters. So now we can calculate that how many number of times they would be crossing each other. So this we can see first round when X is at now here 300 meter, Y is at 200 meter. So it means in every round, Y would be covering 200 meters and X 300 meters. So in the second round, you can say then again, X has completed the same distance. It is here at the same position, but Y would be at 100 meters because here 100 meters was left and another 100 meter would be covered. So because total distance Y is covering is 200 meters. So here this is 100 meters. So still they are not able to cross each other because you can see X was as at this position. Now when it is covering this distance, Y is also moving ahead and it would be at this position. So they haven't crossed yet. And in the third round, we can say now they would be at the same position and they would be crossing each other for the first time. So we can say that in completing 3 rounds, they would cross each other by one time. So number of rounds that had to be completed is 10. So we can now calculate that every 3 round they would be crossing one time. So 3 round, then another 3 round they would be crossing, another 3 round, and then one round would be left. So they would only be able to cross each other by 3 times. So this is a little tricky and we have to think more in this case. So I hope the understanding is clear here. So 3 round plus 3, 6, then 9 round and one would be left because 10 has to be completed. Only 10 rounds has to be completed. So they'll cross only 3 times. Then X, Y, and Z, there are 3 contestants in a race of 1000 meters. So total distance is given. Assume that all run with different uniform speeds. Speeds are uniform, but they are different for each player or each runner. So X gives Y a start of 40 meters. Now X is giving Y a start. So Y is ahead by 40 meters compared to X position. And X similarly gives Z a start of 64 meters. So X is giving Z a start. So it means Z is 64 meter ahead of X. This is the distance of the position. So when we calculate the difference between Y and Z, it would be 24 meters. Now what we have to calculate is if Y and Z they were to compete in a race of this again 1000 meter. So it means for Y, it is the starting point. So this is for this distance is 1000 meter. Now we have to calculate 1000 from Y's position. So it would not be 24 meters. That is why we have to calculate it. So how many meters start will Y give to Z? So here that is why we are not taking 24 meter as the answer because it is not for 960 meters that we have to calculate the start given by Y to Z. It is for 1000 meter. So if in a 960 meter long race, we can get the value to be 24 meters. So for 1000 meters, simply using the unitary method, we'll get 25 meters as the answer. So that is why 25 is the answer. And even 24 is not an option also given. So this is to just remember here that if man takes double the time to row up the certain distance than to row down, then speed of the man is thrice the speed of the water, and similarly the reverse is also true. If the man takes thrice the time to row up the certain distance, then the speed of the man is double the speed of the water. So you can simply say it is just replacing these 3 and 2 figure. Now, the question is if a boat takes 48 minutes to cover 12 kilometers. So two things are given, time 48 minutes. So we need to convert firstly this into hours. So we'll divide this by 60. Distance to be covered is 12 kilometer against the stream. So this is for the upstream data that is given, time and distance. And if the speed of the stream is 2 kilometer per hour, so stream speed is 2 kilometer per hour, then what will be the speed of the boat in still water? So we can calculate the speed upstream because time is also given, distance is also given. So we'll just divide both of these things and we are doing it with 60 because we have to calculate in hours. Time is given in minutes. So it would be speed upstream 15 kilometer per hour. Now, simply the formula that we started with was that's the speed that we calculate for the upstream is x minus y. So it is speed upstream equals to boat in still water, the speed of the boat in still water minus the speed of the stream. So this is x, this is y. x minus y, and downstream would be x plus y. So we have to calculate the speed of boat in still water. So we need to calculate this value. Simply when we take it to the left hand side, we'll add both these because we have these two figures already. Speed stream of this is given to us. We have calculated the speed upstream from here. We need to place the values and we'll get it as 17 kilometer per hour. So we need to just think about which formula would be actually used. And you can also clearly see that we haven't used any of the formulas that we discussed initially, especially the lengthy ones, which are again certain. They are certain confusion also. So it is just simply the common sense, and the equations that you are making, you need to ensure that you are making it in a correct manner. So a boat, it goes 75 kilometer upstream in 3 hours. Again, distance and time is given for upstream. So we have written it for the upstream thing. We have calculated speed from these two variables. And similarly, we have it for downstream. So downstream distance and time is given. Speed is 40 kilometer per hour. So you'll always see the speed downstream would be more than the speed of upstream, always. So downstream, simply this again, the same formula which we saw in this question. For the speed upstream, it is x minus y. Downstream is x plus y. So we have to calculate speed of the boat in still water. So we'll just solve these two equations now, get the value of x. It would be 32.5 kilometer per hour. So x is the speed of boat in still water, y is the speed of stream. We don't have to calculate the speed of the stream, so that is why we'll put the value of y in this equation from this equation. So that's how we have put here y as x minus 25. So x, we can get the value from here, 25 plus y. Sorry, y would be x minus 25 because we are replacing y here. So a swimmer runs 3 kilometer per hour against the stream. So for upstream, the speed is given, goes 1 kilometer in 10 minutes. The time and distance is also given along the stream. But this is for along the stream, means this is for downstream and this speed is for the upstream. And then in how much time will be take to cover 5 kilometer in still water. So always remember it is still water. So first we need to calculate the speed of the still water. So upstream speed is this, which is x minus y. Distance is given, time is given for downstream. Now we can calculate speed downstream from these two again variables that we have, but it has to be in hours. This is in minutes. So it would be 6 kilometer per hour for downstream. Now again, same application or the same method to solve x minus y and x plus y, because we now have the values for both of these equations. So we'll just solve them. We'll get the value of speed of the boat in still water would be 4.5 kilometer per hour. We have to calculate how much time will it take to cover 5 kilometer in still water. So now we have the speed of still water, we have the distance. We need to simply calculate the time by this formula, and time would be 10 by 9 hours. Then a boatman goes 44 kilometer downstream, 30 kilometer upstream, takes 10 hours, while it takes 13 hours to go 55 kilometer downstream and 40 kilometer upstream. Find the speed of the boat and the stream. So here two cases are given. So you need to focus here that time 10 hours is given for both 44 kilometer downstream and 30 kilometer upstream. It is addition of both. Total time is 10 hours. Similarly, in case 2, total time is 13 hours for both downstream and upstream. We have the distance. We have to calculate the speed of the boat and also of the stream. It means x and y has to be calculated. So case 1, distance, downstream distance, upstream distance, time is 10. So simply the equation would be used total time, because time is distance upon speed. So here distance upon speed for downstream plus distance upon speed for upstream. That's how we'll get the total time taken by adding these two things. Similarly, for case 2, exactly same language for the second half of the question is there. So we'll make the equation on same logic. Now here we will cross multiply these factors in order to simplify the solution. So since 40 is here, so we'll multiply this equation with 40, and here 30. You can use 44 also, but 30 would make it more simpler and easier to solve. So we'll cross multiply this equation with 30. So that's how we'll get these variables, and this factor will cancel out. And when you further solve it, you will get the value of this equation x plus y is 11. So further, when you use this value here in this equation, you will get the value of x minus y also, and then you solve these two equations to get the value of x and y, which was to be calculated. So this is the speed of the boat in still water, and this is the speed of stream, which is y. Now a boat goes 48 kilometers in 20 hours, so distance and time is given to us. In still water, when nothing is mentioned, it means the speed and distance is always for the still water. So it takes 4 hours more to cover the same distance against the stream. Against means it is talking about upstream. So upstream distance remains the same because it is stated, so 48 kilometers. Time is 4 hours more. So 4 hours more than 20 hours would be 24 hours for upstream. We can calculate the speed, and although however it is not mentioned here what you have to calculate, but it is the given the options, so it is the speed upstream that had to be calculated. So if a boat goes 100 kilometer downstream in 600 minutes and the speed of the stream is also given, speed of the boat in still water has to be calculated. So downstream, the information is given, so time converted into hours by dividing by 60 minutes. So speed would be 10 kilometer per hour for downstream. The speed of the stream would be 5 kilometer per hour, which is given to us. So simply downstream is x plus y is 10, which we calculated, and we have the value of y. So we had to calculate x, speed of the boat in still water. So it is 5 kilometer per hour. Now, man takes half time in rowing a certain distance downstream than the upstream. So simply we have written this statement in equation form. Time taken downstream, half the time taken upstream. We have to calculate ratio of the speeds in still water to the speed of the current. So it means we have to calculate ratio of x is to y. Now, because distance remains the same, so d would be the variable that we'll use, and time, so we'll then further solve it as the equation for time is distance upon speed. So this is distance, this is the speed downstream, x plus y half into distance upon again the speed upstream. So because we have to just simply calculate the value of ratio, so that is why it is simpler to calculate. We don't have to further solve it. So it would be 3:1. A man can row 7.5 kilometer per hour in still water, and if in a river running at 1.5 kilometer per hour, so this is the speed of stream which is given. It takes him 50 minutes to row to a place and back. How far off is this place? So simply, you just have to first write all the variables that are given to us. Think about what you can calculate next on the basis of what has been asked in the question to solve for. So it is again simply the same formula that we've seen in the previous question. Total time would be again distance upon speed, both the ways, downstream and upstream. So you solve it further. Time is, it is given, and we have calculated here total time taken. We'll put the value here, we'll get the value of d, which was to be calculated because it is asking how far off is the place. So total distance is 3 kilometers. Then a boat can travel with the speed of 13 kilometer per hour in still water. So it means it is x, the value of x is given. If the speed of the stream is 4 kilometer per hour, so this is the value of y. To find the time taken by the boat to go 68 kilometer downstream. So simply we can calculate the speed firstly downstream, which would be addition of these two variables, which is given. We have the distance downstream that is to be covered. Simply time has to be calculated. So we'll divide these two and it would be 4 hours. So that's all in this particular session regarding time and boat. I hope the questions are clear. These are little tricky, but when you solve them, you'll get more clarity and confidence. So thank you so much for joining us on Ansarkari, and stay tuned for further detailed sessions, particularly on CSAT.